Hello everyone, welcome to another episode of Coding Interview Practice. So today we are going to talk about the sliding window pattern. So you might have faced some problems that ask you to find the longest substring without any repeating characters, or find the longest substring with at most two distinct characters, or find the smallest subarray with this condition or that condition. So as soon as you hear the keywords of substring and subarray, it's worth to think about the sliding window pattern. So how does it work? In sliding window pattern, we have a window that we start expanding it until we violate the problem's condition. And then at that point, we start shrinking that window. And during this procedure, we keep track what's going on inside the window. So this is the core idea of how a sliding window works. We start with two pointers. One pointer points to the start of the window, the other pointer points to the end of the window, and we keep expanding the window by increasing the end point, end index, until we violate the condition. And then at that point, we start shrinking the window by adding to the starting index. When the condition is satisfied, then we expand the window again until we violate the condition, and then we shrink the window until the condition is satisfied. And during this procedure, we keep track of the results. Now, let's look at one of the problems. Let's solve it with this technique. And actually, this is one of the problems that labeled as hard in Leetcode. The problem is this. So given a string, find the length of the longest substring that contains at most k distinct characters. So for this example, so we are looking for the longest substring that contains at most two distinct characters. So one substring is ECE. We cannot add B because then it'll contain three distinct characters. So this is one. The other one is BAA. So the maximum length of such substring is 3. And what about this one? Again, we are looking for the longest substring that contains at most two distinct characters. So one is 1, 2, 3, 4. The other one is 2, BA. The other one is 6. So, and this substring only contains what? A and C. So it satisfies our condition, at most two distinct characters, and the output is 6. Same string, but with at most one distinct character. One substring is AA, which has a length 2. The other one is B, which has a length 1. The other one is A, which has a length 1. The other one is CCC, which has a length 3. And the other two is A and C, each with length of 1. So the maximum length of such substring is 3. So let's see how we can apply the sliding window strategy to solve this problem. So A, B, A, C, 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 and A and C, and we're looking for the longest substring with at most two distinct characters. So let's index our string 0, 1, 2, 3, 4, 5, 6, 7, 8. So as I mentioned, we start with start index and end index. And we have to keep track of what's inside our substring, okay? So for that, I use a map. So let's expand our window. So we don't have anything in the window. So we add A and its index in the map. So because A is new to the map, it means that I've added a new character. So I have to decrease K from 2 to 1. But still, I have room because I'm looking for at most two distinct characters. So I still have one distinct character to add. So what's the length of my substring so far? The length of substring would be the end index minus the start index plus 1. So end index is 0, sorry. The start index is 0 plus 1 is 1. So this is my result I'm looking for. So far, the substring I have is just this one. Let's expand it. So A is already in the map. I'm not adding anything new. I'll update the map to have the latest A that I've set. The index of A, the latest one is 1. I expand again. B is not in the map, so I add it to the map with its index. Because it's new, I decrease k. Oh, by the way, like at every step, I have to keep track of the length. So what's the length now? So 2 minus 0 plus 1 is 3. And because 3 is more than 1, so I keep track of the 3. So let's expand again. I'm not violating the condition yet. So A is already in the map. So I just update its index. Let's expand it. C is not in the map. So I add it to the map with its index. And because it's new, I decrease K again. So here, I am violating the condition of maximum 2 distinct characters because my string now has 3 distinct characters, right? These 3. So now it's time to shrink until I satisfy the condition again. Remember that because now I'm violating the condition, I'm not calculating the length of the substring because that would be wrong. Like if I want to calculate the length of this substring, this is wrong because it contains 3 distinct characters, not 2. So let's shrink the window. So I remove this A from my substrings by increasing the start index, but the A that I exclude has index 0. But the latest A that I have in my substring has the index 3. So that means that I still have A in my substring, okay? So still the condition is violated. So I keep shrinking. Another A that I'm ignore is 1. Still, it's not 3. So it means that I have A somewhere else in my substring. I exclude B, and B has index 2, and the latest B that I saw was at index 2. Okay, that's good. So it means that I don't have B anymore, and I can increase K, and at this point, the condition is satisfied. So again, I'm eligible to expand my window. So, but before I expand, what's the length of the substring? So the length of the substring that I have is 4 minus 3 plus 1 is 2, but 2 is less than 3, so I don't consider that as my result. So let's expand again. So C is 5. Okay, that's good. So C already is in the map, so I just update its index. I expand again. C is 6, so I just update its index. A, so A is in the map, so I just forgot to basically check the length. So again, like at every step, we have to check the index. So far, what's the length of the substring? It's 7 minus 3 plus 1, it's 5. So and 5 is larger than 3, so now we found a larger substring. Cool. So still everything is okay, we can expand again. So C is already in the map, so I don't decrease K. And what's the length? So 8 minus 3 plus 1 is 6. And I just hit the end of the array, and that's it. So basically the largest substring that we found is 3, which is this substring that has at most 2 distinct characters. Cool. So I hope that's clear. Let's talk about the time complexity. So in the worst case, we traverse the array, one for the end pointer, the other one for the starting index and end index. So in the worst case, we traverse the array 2 n times, which is equivalent to O of n. This is the time complexity. What about the space complexity? For space complexity, we use a hash map, right? So what would be the worst case for map? So it depends on the maximum number of distinct characters that we allowed to have in our substring, right? Basically, the space complexity would be O of k. So often when you're using this sliding window pattern, the time complexity is often O of n, unless you are doing something like extra computation in between to keep track of your results within the window. And the space complexity really depends on the problem. So it's not a general rule. It really depends on the problem at hand. But as long as you know the core idea, you should be able to tackle such problems. Okay, so now let's write our method. So first of all, when input is empty, or k is 0 as well, so we don't have any substring, right? So the answer should be 0. Now, okay, now let's have our start index and end index. For default dictionary that has the input as its default value. Now now what should we do here? We have to start adding or expanding our window, right? So expanding the window. So if input of end index not in scene, it means that we are adding a new character to our substring. So we have to decrease k, and we have to add scene of input end index is equal to end index. Okay. Now, so we have to, before we actually keep track of the result, so here I forgot to add result is 0. Before we keep track of the result, we have to check whether the condition is valid. If it's not, then we have to shrink our window. So y k is less than 0 if scene of input start index is equal to start index, means that's the latest character that we have in our, that's the latest of that specific character we have in our string, and we are excluding it. So then we can add to our k, and then we say result is equal to max of results and end index minus start index plus 1. At the end we return results. Let's see if it works for our test samples. Okay, so I guess here I made a mistake. Okay, now let's see if it works. Okay, so 3, 6, oh, last one, there's a problem here. Let's see where we made the mistake. Oh, okay, I found the issue. So basically here, when I remove the character completely from our list, I have to remove it from my map. Otherwise, it still thinks that it exists in the substring, right? So basically, as soon as this condition is satisfied, that means that I do not have this character in my map anymore. So I have to delete that. Delete scene input start index. Let's run it again. Three, 6, 3. Cool. So it looks like it's working. And we've already talked about the time complexity, which is O (n), and space complexity, which is OK. Hope you enjoy another episode of Coding Interview Practice. Don't forget to subscribe and like. Until the next episode. Peace.